All right, guys, in this next video, we're going to look at memory storage. So let's start. So current theories of memory storage propose that incoming information must pass through two temporary storage buffers, sensory memory and short-term memory, before it can be transferred into long-term storage. Sensory memory preserves information in its original sensory form for a very brief time. In a classic experiment by George Sperling, he demonstrated that sensory memory storage lasts for only a fraction of a second. His subject saw 3 rows of letters flashed on a screen for just 1/20th of a second. After a brief delay, a tone was sounded. The pitch of the tone signaled which row of letters the subject could report. So if you remember back to the chapter we did on research methods, the independent variable in this experiment was the length of time for the delay before the tone was sounded, signaling the subject to respond. I'm going to click on each of the numbers along the x-axis to see the percentage of letters recalled correctly after a delay of that length. So, 80%, 65%, 50%. At half a second, it was about 40%. And after about a second, it was about 33%. So as the delay increased to 1 second, subjects' recall accuracy actually declined. So why? It seems that because the memory trace in the visual sensory store decays in about 1/4 of a second. So if you see something and you don't commit it to memory, in about a quarter of a second, it tends to disappear. Now we're going to talk about short-term memory. Short-term memory is a limited capacity store that can maintain unrehearsed information for about 20 seconds. Actually, you can maintain information in your short-term memory for longer than 20 seconds by engaging in rehearsal, which is the process of repetitively verbalizing or thinking about the information. You surely have used rehearsal to keep information active in short-term memory. For instance, when you obtain a phone number from the operator, remember that? You probably recite it over and over until you can dial the number. This way you don't forget it. Our dependence on recitation to maintain information in short-term memory is apparent from the kinds of mistakes we tend to make when our efforts break down. For example, suppose you were asked to remember a list of random letters such as these: Q, P, L, H, S, and X. Mistakes on this task usually involve acoustic confusion, in which the incorrect answers sound like the correct answers. For example, you might mistakenly convert P to E because they sound alike. Even when information is presented visually, we tend to make acoustic mistakes because we largely depend on phonemic encoding in short-term memory. Without rehearsal, information in short-term memory quickly decays, as a study by Peterson and Peterson demonstrated. After a warning light appeared, subjects were given 3 consonants and a 3-digit number to remember. To prevent rehearsal, the subjects started counting backwards by 3s from the number given until they saw a light that signaled the recall test. The independent variable in this study was the length of the delay before the recall test, which varied from 3 to 18 seconds. The dependent variable was the subject's retention of the 3 consonants. The results indicate that when people cannot rehearse, material is quickly lost from short-term memory. Without rehearsal, the maximum duration of short-term memory storage is only about 20 to 30 seconds. All right, let's take a look to make sure you understand everything we just talked about. So, in this diagram of the Sperling study, click on the graphic that represents the manipulation of the independent variable in the Sperling study. Let's see, was it this one? No, it was not. Was it this one? It was. And in this diagram of the Peterson and Peterson study, Click on the measurement of the dependent variable. Let's see, was it this one? No, it was not. Was it this one? No, it was not. It was this one. So click on the memory store that depends on phonemic encoding. We think short-term memory. And on the sensory store that preserves information in its original sensory form, that would be sensory memory. Okay. So short-term memory has a limited capacity. It can only hold about 7 plus or minus 2 items. When short-term memory is filled to capacity, the insertion of new information often displaces the information already available in short-term memory. So there's a capacity to what you can remember in short-term memory. For example, if you're memorizing a list of 10 states that have passed a particular law, the 8th, 9th, and 10th items on the list may bump earlier items out of the short-term memory store. You can increase the capacity of your short-term memory by combining stimuli into larger, possibly higher order units called chunks. A chunk is a group of familiar stimuli stored as a single unit. To demonstrate the effect of chunking, try to remember the sequence of letters shown here. Now type the letters as you remember them. I didn't look at it that quick, but I think it was like FBI, IBM. That's all I remember. So in the original sequence, because there are no obvious groups, you probably, like I did, attempted to remember each letter separately. But a string of 12 letters is too long for short-term memory, so errors like I made are likely. But what would happen if you grouped the same letters differently and try to remember them this way? The letters now form four familiar chunks that should occupy only 4 slots in short-term memory, increasing the likelihood of successful recall. So FBI, NBC, CIA, IBM. So now, instead of trying to remember the individual letters, you're remembering the 4 groups of letters. Years of research eventually showed that short-term memory involves more than a simple rehearsal buffer, as originally envisioned. A researcher by the name of Alan Badley had proposed a more complex working of short-term memory that characterizes it as working memory. According to Badley, working memory consists of 4 components, which are shown in the diagram. And we'll click on each one to see what it does. So the first one is the phonological rehearsal loop. So the phonological rehearsal loop is the acoustic recitation system that represented all of short-term memory in the original model. Then, the executive control system. The executive control system handles the limited amount of information that people can juggle at one time as they engage in reasoning and decision-making. This component is at work when you mentally weigh all of the pros and cons before deciding whether to buy a particular car or a particular TV, that kind of thing. And then we have the visuospatial sketchpad. So the sketchpad permits people to temporarily hold and manipulate visual images. This component is at work when you mentally rearrange the furniture in some room in your house. Then we have what's called the episodic buffer. The episodic buffer allows the various components of working memory to integrate information and serves as the interface between working memory and long-term memory. Now let's talk about long-term memory. So long-term memory is different than sensory and short-term memory because it has an unlimited capacity store that can hold information over a lengthy period of time. Unlike sensory memory and short-term memory, which decay rapidly, long-term memory can store information indefinitely. Because it houses a vast amount of information, organization is crucial for long-term memory. Research suggests that we employ a hodgepodge of overlapping organizational frameworks in long-term memory, including things called conceptual hierarchies, semantic networks, and schemas. And I'll click on each one to help you understand it a little bit more. So, a conceptual hierarchy is a multi-level classification system based on common properties among items. A conceptual hierarchy that a person might construct for minerals is shown here. Then we'll look at semantic networks. Semantic networks consists of nodes representing concepts joined together by pathways that link related concepts. A small semantic network is shown here. The ovals are the nodes, and the words inside the ovals are the interlinked concepts. The lines connecting the nodes are the pathways. Shorter pathways imply stronger association between the concepts. And then finally, a schema. A schema is an organized cluster of knowledge about a particular object or event abstracted from a previous experience with that object or event. We have schemas for various types of people, such as sophisticated professionals, working class stiffs, this is a little dated, for inanimate objects such as tables, and for human activities such as eating lunch. We are more likely to remember things that are consistent with our schemas than things that are not. All right, let's see what we got here. Drag and drop the two descriptions of storage capacity shown here in the correct slots in the table. So, short-term memory, storage capacity, 7 plus or minus 2. And long-term memory, no known limit. All right, then we have storage duration for sensory memory. Quarter to 2 seconds. Short-term memory, up to 20 seconds. And long-term memory, minutes to years. Okay. So if you take a look at this picture, it shows the influence of schemas. Imagine that you've just visited Professor Smith's office, which is shown in this photo. Take a look at the photo before it disappears. Now pretend that you want to describe Professor Smith's office to a friend. Click on the items listed here that were in the office. Select as many as you like, and then click on the Done button, which I will do because you can't manipulate this. I can. So let's say it was an office. I would say there's a filing cabinet. I would say there was a table. I would say there's a bulletin board, a lamp, a chair, some books, shelves, typewriter, maybe a coffee pot. Let's see if we got it right. So if you remembered seeing several things that were not in the picture, which I didn't, your mistakes show how schemas can influence memory. You have a schema for a professor's office, and you are more likely to remember things that are consistent with your schema than things that are not. So for instance, here's the office, and there was a picnic basket. Let's see, there was a coffee pot. Thought I saw, but maybe I was wrong. A globe. Okay. Two researchers, Brewer and Trenez, tested the recall of subjects who had briefly visited the office. Few recalled the wine bottle or the picnic basket, which aren't part of the typical office schema. But 9 of the 30 subjects in the study falsely recalled that the office contained books, because books are part of one's schema for a professor's office. Thus, the recall of objects or events is influenced by both the actual details observed and one's schemas for these objects and events. Okay, that ends video number 2.